Our next question is questions 12 to 14 refer to the following information. So we have the following information. Let's read the question first. In 1919, H.S. Reed and H.S. Holland published a paper on the growth of sunflowers. Including in the paper were the table and graph above. So we have been given a table and a graph here, which show the height h in centimeters of a sunflower t days after the sunflower begins to grow. So in the table we have been given two columns where we have days and height in centimeter. Also the time in days represented on the x-axis and height in centimeters represented on the y-axis, and by combining the points we got the curve of this function. So the question is, over which of the following time period is the average growth rate of the sunflower least? And we are given four options from 0 to day 21st, day 1 to day 42, day 42 to day 63, day 63 to day 84. So we want to show the growth rate of the sunflower least. The average growth rate is the slope of the line segment that joins the point on the graph in certain time periods. So if I find the slope on the graph on different time periods, I can find the growth rate of the graph. So from the graph I can easily see the more inclination of the graph will give me the highest growth rate, and the less inclination or less steeper slope of the graph will give me the least average growth rate. So from here I can see day 63 to 84. From day 63 to 84, it is less steeper and less inclinated. The slope of the function here is lesser than the slope of the function in other four periods which were given from 0 to 21 and 21 to 42 days, 42 to 63 and so on. So it means the option D is the most appropriate option. So we have been given four time periods. The slope is least from day 63 to day 84. So I can write down here, the slope is least from day 63 to 84. So option D is the correct option. Our next question is, which is also related to this information, the given information. Question is, the function h defined by ht is equal to at plus b, where a and b are constants, models the height in centimeters of the sunflower after t days of growth during a time period in which the growth is approximately linear. What does a represent? So it says the growth rate is linear. It means there is no change of growth rate throughout the limit. Based on the definition, the function when the value, the function we have ht is equal to, function we have ht is equal to at plus b. When the value of t increases by 1, when value of time, which is t, increases by 1, the height of the sunflower increases. The of the sunflower increases by a centimeter. So option A, which is the predicted number of centimeters the sunflower grows each day during the period. So it is the predicted number of centimeters. A is the predicted number of centimeters. Our next question is also related with the above information. The question is the growth rate of the following. The growth rate of the sunflower from day 14 to day 35 is nearly constant. Means there is no change of growth rate from day 14 to day 35. So here we have day 14 to day 35. There is no change in growth rate from day 14 to day 35. On this interval, which of the following equations best models the height h in centimeters of the sunflower t days after it begins to grow? So if I find the slope of the line from day 14 to 35, I can find the equation. If so, I can say, according to the table, let t1 is equal to 14 and t2 is equal to 35. What does it mean? It means t1 is the first day, which is 14, and t2 is the last day, which is 35, and h1 is the height at first day, and h1 is the height on the day 14th, which is 36.36 centimeters, and h2 is the height at the 35th day, which is 131 centimeters. Each day the height of sunflower increases by approximately. Height of sunflower increases approximately increases by approximately equal to the change in height divided by the change in time. So we can easily see the change in height is equal to h2 minus h1, which is, and the change in time is equal to t2 minus t1, which is equal to h2 is equal to 131 minus h1 is equal to 36.36, and the change in time is equal to 35 minus 14. So it's approximately equal to 4.5067. So if we round off the figure, it will give us 4.5 centimeter. So the equation that show the height of the sunflower t days after it begins to grow will be, for h is equal to 4.5 t plus c. Actually, it is the slope of the line, which is 4.5 centimeters. It gives me that if the time changes 1 unit, the height will change 4.5 centimeters on each unit change of time, which is in days. It means each day it gives me the change in height will be 4.5 centimeters. Let me arrange the data so we can find the y-intercept of this equation. We can find the c by using any order pair of time and height. So I'm going to move this data through the left side so we can arrange it first. So by using any order pair of th, we can find the value of c. So I'm going to use the first order pair, which is at 14th day the height will be 36.36. So t is 14 and the height h is equal to 36.6. So I'm going to put h is equal to 14 and t is equal to 36.6 in the equation number 1, which is 36.36 is equal to 4.5, and I'm going to substitute 14 instead of t plus c. So c will be equal to minus 26.64. So h will be equal to 4.5 t minus 26.64. So the closest and the best model among these options will be the option number B. Question is, which of the following equations relates y to x for the value in the table above? So in the above table we have two rows. The first row gives us the value of x, which is increasing by 1 unit, 1, then 2, then 3, then 4, then 5. And second row gives us the value of y. So we need to find which of the following equation represents y to x for the value of the table above. From the table we can find the relation between y and x. So if x increases by 1, how much y is going to increase? So we can subtract the second value of y from the first value. Let me see how much change is occurring in y. So 25 by 4, let me do it on the left side. 25 by 4 minus 11 by 4, which is equal to 14 by 4 is equal to 7 by 2. So it means the value of y increases by the value of y increases by 7 by 2 when x increases by 1. So we can present this relation with in the equation y is equal to 7 by 2 times x plus c, which is equation number 1, where c is the constant. Any order pair from the table must be satisfy equation number 1. So I am going to choose the first order, which is when x is equal to 1 and y is equal to 11 by 4. Let me write down first. Any order pair must satisfy the equation 1. So I'm going to use the order pair x is equal to 1 and y is equal to 11 by 4. I'm going to put that 1 is, and I'm going to substitute these values in equation number 1. So y is equal to 11 by 4 equal to 7 by 2 and x is equal to 1 plus c, which is equal to 11 by 4 minus 7 by 2 is equal to c. Let me arrange this, or I'm going to move this on the right side. So c is equal to 11 minus 14, which is equal to minus 3 by 4. Substituting the value of c in equation 1, substituting in 1, y is equal to 7 by 2x minus 3 by 4, which is option number D. So this is the correct answer. Let's move to the next question.